everyone, my name is Varat Bhatnagar and today I'll be presenting our paper titled Harnessing Abstractive Summarization for Fact Check Claim Detection, which has been accepted as a long paper at COLING 2022. Uh, I'll be using the following points to go over our work. To start with, fake news can be loosely defined as any form of misinformation that is spread with a malicious or a non-malicious intent among the masses, and it is well documented that fake news has the ability to trigger events which lead to loss of life and property. Some of the events I have listed here. It is seen that fake news has had a major role to play in changing the political narrative around events such as presidential elections, and it has also led to violent incidences in the Indian subcontinent because it has targeted the religious beliefs of people. So, the fake news detection techniques can be classified at a high level into two buckets: the manual efforts and the automatic efforts. The manual techniques are typically owned by journalistic organizations such as Snopes and PolitiFacts in the US and Alt News, Boom Live, and Factly in India. These techniques suffer from inability to scale due to the rapid dissemination of fake news and involvement of human element. Whereas the automatic fake news detection rely on NLP, deep learning, and web retrieval to build systems to detect fake news, and they suffer from data overfitting and poor generalizability. Here is a glimpse of a typical fact checking pipeline. Uh, there are four stages. The first stage involves checking if a claim is worthy of a fact checking effort or not. The second stage involves checking if similar claims have been fact checked in the past or not. The third stage involves evidence retrieval for against a claim, and the fourth stage, a verdict is passed whether a claim is true or false based on the evidence and the similar claims that we have retrieved in the past stages. So, semi-automatic fake news detection techniques um, try to automate some of these subtasks, which are relatively easy, and leave others for humans. So the focus of this work is going to be the second stage, and we aim to partially or fully automate this stage using this work. Definitions and tools that are a part of this work. Social media claim (SMC) is a social media post that contains a claim. Fact checking article (FCA) is basically an article published by any fact checking organization which accepts or refutes a claim. Summary of claim review (SCR) is a short summary of the claim added by the publishing organization, and CCR is the condensed claim representation, which is basically the summary generated by our models. Now here is an example of the fact checking articles from different websites. Here is how they look, and this is the claim review schema, which is basically the metadata of the fact checking article shown in the previous slides. There is a field called the summary of claim review, which is basically a summary of the claim that has been added by the human fact checkers, which serves as the gold summary for our dataset. And here is an example of the social media claims and their gold summaries extracted from the metadata of the articles. So if you notice, the SM social media claims are extremely noisy in nature because they have been taken from Twitter, and the social and the reviews are very clean because they have been written by journalists. The Google fact checking engine is another tool that is being used in this work. So this is a it is a search engine that can be used to search for fact checking articles, and it is constantly updating itself with the latest articles around the world in different languages. So this is the workflow given in the paper, our proposed workflow. So on the top left side, the output of the checkworthiness estimation is seen, which is the social media claim. And if you follow the dotted lines, you will see how previously proposed workflows dealt with this problem. They directly took the social media claim and used the retriever to get a set of similar claims. Whereas in this work, we have added a source specific pre-processing module as well as an abstractive summarization module before querying the retriever. So the objective of the source specific pre-processing module is to get rid of the noise, as most of these SMCs are coming from Twitter, Therefore, it is full of slangs and abbreviations. That is why this is required. And this abstractive summarization module uh, creates a very crisp and short summary of this social media claim, which can be used to query the retriever and get the set of similar claims. So, moving on to our data sets, the need to curate our own data set was felt because of these two reasons. So, most available summarization data sets are at a document level, whereas this work required a data set at the tweet level. And the other reason was that most of the summarization data sets available in the literature are clean in nature because they've been taken from books, news articles, and blogs. But it is seen that fake news thrives in noisy settings such as social media, instant messaging, and such apps. That is why we required a data set in a noisy setting. So here is our curation strategy. We look for fact-checking article tweets, fact-checking article URLs in the comments of tweets, and such pairs are extracted from Twitter. And the summary of the claim review is derived from these fact-checking articles. And then there is a manual annotation effort which checks if the social media claim is summarizable to its corresponding summary or not. And we also annotate manually the language and the topic. So here is a distribution of the data set. On the right hand side, we can see that politics and religion are extremely dominant in this data set, which are themes which divide public opinion in India. And health is also a significant topic because the data gathering timeline overlaps with the COVID 19 pandemic. And here are the dataset statistics. So our dataset is listed in column 2, and this Snopes dataset from Shah et al is listed in column 1. And our dataset size is 567 pairs, out of which there are 531 unique SMCs and 369 unique SCRs, which shows that there is a degree of non one to one correspondence in our data. The other thing to note here is that the median length of the summary of claim review is 11 words. We use this as a target length when we train our models. And our dataset also has a higher word level TF-IDF cosine similarity because it is a summarization dataset, whereas this Snopes dataset is not a summarization set. So this is an encouraging sign before we train our summarization model. Moving on to the experiments, these are the experiments that we perform. First, we establish the baselines. The verbatim querying baseline is basically taking the SMC and directly querying the Google fact check engine without any kind of pre-processing or abstractive summarization performed on it. And the other baseline is the truncate 11 baseline, where we truncate every SMC to the first 11 words. Uh, then we experiment with different Twitter-based aspects such as hashtags, mentions, and emojis. Different pre-trained models are fine-tuned, such as T5, BART, and Pegasus. We also experiment with different decoding strategies such as greedy, beam, and nucleus sampling. And we also investigate recall plateauing and parameter scaling across different models. So these are the pre-trained models that are used in our work, T5, BART, and Pegasus. If you look at the rightmost column, we can see that the parameters of our model vary from 220 million to 370 million. This is the standard transformer architecture, the different decoding strategies that we are using in this work. And moving on to the parameter scaling aspect. So we experiment with many variants of T5 which have the same learning objective, but the number of parameters are different, from varying from 60 million to 11 billion. So we study the retrieval performance gain as a function of the parameter scaling in this study. And the evaluation metrics used in this work for the summary quality are word level similarity, blue score, and TF-IDF cosine similarity. For the retrieval evaluation, we use recall at K and mean reciprocal rank, which are the standard metrics in any retrieval system. Over some of the results of this work quickly. So, on the left hand side, the graph shows the effect of parameter scaling. So, the takeaway here is that the T5 model always performs better than the T5 base model, but the slight gain in performance is offset by the larger training time. Hence, we do not take this path. On the right hand side, different decoding strategies are investigated, and it is seen that beam search with a beam size of 6 performs the best. Now here we try to motivate why we chose recall at 5 as our metric to report retrieval. So the reason is that when we plot recall at k for all values from 1 to 50, an elbow is seen at recall at 5, after which it plateaus. So that is why recall at 5 was chosen. In this table, the retrieval results are listed for our experiments. And the thing to note here is that without any summarization, only 9.52% retrieval is obtained, whereas this value jumps to 30, close to 35% when we on our best model after summarization. So the other takeaway, and this numbers has to be taken in context with the skyline value, which is just 64%, which is pretty low. So that is why this 35% number is pretty high when seen with this skyline value. Then the other takeaway from this is that the contribution of our data set. So if you look at column number 2, all these models over here are used out of the box, and in column number 3 they are used when after supervised training on our own data set. And there is a huge performance jump because of this fine tuning on our own data set, which shows its utility. And the third takeaway here is that even for languages where such datasets are not available, the out-of-box performance of these models are very good, and they are able to give a better recall compared to no summarization. So yeah, these were the takeaways, and here are the quality metrics for our work. So it can be seen that the summaries generated by our model have got very high blue scores, and even the TF-IDF cosine similarity between the summaries and the gold summaries are very high. Here are some qualitative results. If we go over the results, it is seen that the summaries generated by the model given in the last column for the claims given in the first column are pretty short and crisp and accurate. They are able to capture most of the claim content in the noisy tweets, except in point 4, where the model is unable to reason that number which is higher in ranking is actually a worse rank compared to a number which is lower. So to summarize, we propose a novel workflow for detecting previously fact-checked claims using abstractive summarization, and we have curated and annotated a tweet-level dataset for the same task, which we also release with this work. And we also perform a lot of experiments with a variety of preprocessing techniques and open source pre-trained models, and we also explore the qualitative analysis of each and every aspect of our pipeline. So this work is easily extendable to other languages. Our data gathering mechanism can be copied for other languages with annotator support, and it can be extended to other languages also. For other modalities, the text summarization module can be replaced with the text generation modules to support image, text, and video claims. We have not covered these things as part of this work, but it can be an interesting future direction. Some other future directions for this work can be to explore this graph-based linkage. Basically, the non-one-to-one correspondence that was seen in the data can be used to can be an interesting way to move this work forward. And it can be extended to this other subcontinental languages such as Hindi. Then there is some papers on controlled generation using named entities, as named entities are very important in any work related to fact checking. And this whole work talks about the Google fact check engine, which is a black box retriever. So attempts can be made to build a white box retriever and then check performance of these experiments on that. So yeah, that's all. Thank you so much. I'll be happy to take any questions.